Hello, you're welcome back. All right, so we're still on integration, and we'll continue from where I stopped. So, this is another technique of integration, and we're looking at integration by partial fraction. Okay. Now, when do you apply the integration by partial fraction? Now, whenever you have a question of the form, a question, okay, whose function, an integral value whose function can be split into sum of partial fraction. That is where we apply this. For example, okay, if you are being given such a question, integral value of s3x all over s squared minus 5x then plus 6 with respect to x, okay, to evaluate. Now, if you look at this, okay, this cannot, there's no way I can actually evaluate the integral value of this using the technique I've already introduced previously, okay. This is not even the function of a differential function, okay. It's not even a function of a function, all right. And one of the ways that I can apply, okay, or the only way that I would definitely apply, the only process that will help me get the value of this integration is to split this function into two partial fractions. Then I now integrate the two partial fractions individually, okay. But first, what do? I have to, okay, of course, you know how we work on partial fraction. I have to factorize the denominator. If you factorize this denominator, okay, you will have x minus 2, then x minus 3. Okay, so you can actually do that, try that. Of course, you know that if you want to factorize, you multiply the first term and the last term. That is going to be 6x squared. Okay, then you now find two factors of 6x squared, which of course is going to be 2x and 3x. And of course, I need to add minus to them so that when I add it together, it should give me minus 5x. Okay, so that by the time I now take this factors minus 2x minus 3x into this expression, of course it's a quadratic expression, I'm going to have s squared minus 2x minus 3x, okay, then of course plus 5. Then I can now factorize this the two binomial expression, okay. There are 4, so as I factorize I group it two binomial expression, then I factorize them individually. So I'm having the common factor of s squared minus 2x is x. Of course, I've opened a bracket, so I'm having here x minus 2. Then I'm having the common factor. Please pardon me. This is 6. This is 6. Okay, so what I have? Okay, so what I have is 6. Okay, the common factor between minus 3x and 6 is, of course, is minus 3. Open bracket. That's going to be x minus 2. Okay, so of course, by factorizing, x minus 2 is a common factor in the bracket, then open another bracket, x minus 3. So this is just factorizing, a very simple way of factorizing quadratic expression. So that's how I got this. All right, so now I can now split this into a partial fraction. Of course, you know how we do that. So this is equivalent to the integral value of the first partial fraction, which I don't know the numerator a. Then of course it will take x minus 2 as a denominator with respect to the x, okay, then plus the integral value of the other partial fraction, which the numerator is b. I don't know what it is, I need to find it. Okay, then it takes x minus 3 as a denominator, the x. So now it's only when I found this a and b, okay, that I will now be able to evaluate this integral value. So now let's see how we do that. Of course, you know what I would do, so let me just leave the integral first. I want to get my a and b, so I'm going to have 3x divided by x minus 2 times x minus 3. Okay, it's equivalent to a, okay, all over. Or better still, let me simplify the fraction, okay, at once. The LCM of the denominator is x minus 2 then times x minus 3. Then I divide x minus 2 divided x minus 2, I have x minus 3. Then x minus 3 must multiply by a. Okay, I have a times x minus 3, then plus s minus 3 cancel s minus 3. I'm left with s minus 2, then multiply by b. b multiplied by x minus 2. Okay, so we've already treated this one with the partial fraction. Of course, you know that I'm going to cancel out the common denominator at both sides. So I'm left with 3x being equivalent to a open bracket x minus 3. Okay, then plus b open bracket x minus 2. So how do I get my value of a and b? Okay, so I would get my a and b by eliminating one of the brackets. If I want to get b, I will eliminate the bracket. Okay, that's I will eliminate a by making the bracket that's attached to a to be 0. So how do I do that? I will do that by putting x to be equal to 3. So if I put x to be equal to 3, that is going to be this bracket is not going to be 3 minus 3, which is 0. Okay, so let's do that. Any place I see s, I put 3. So this is going to be 9 times 3. 3 times 3, please pardon me. 3x is going to be 3 times 3 equal to a into 3 minus 3. Okay, then plus b bracket open. I'm having what am I having here? Okay, bracket that's gonna be 3 minus 2. So if we do that, it's gonna be 9. And this is 3 minus 3 is 0. 0 times a is 0, so I'm left with b. And 3 minus 2 is 1, so I have my b to be equal to 1. Alright, so how do I get my a? I have my b to be equal to 9, please pardon me. So my b is equal to 9. How do I get my a? Okay, if I want to get a now, in this time around, I'll have to eliminate b. And how do I eliminate b? I'll have to put, okay, s to be equal to 2. That way this bracket will be eliminated. So that's gonna be 3 times 2, which of course is 6. Okay, then I'm having a bracket opened 2 minus 3, then of course plus b bracket open 2 minus 2. So what happens? This actually gives me 0. I'm left with this 2 minus 3 is minus 1. So a minus 1 multiplied by a will give me minus a. So invariably a now is going to be equal to minus 6. So I can now evaluate my integral value. So now the integral value of 3x divided by x minus 2 and x minus 3 times s minus 3, okay, will be splitted into two integral values, in which one is a, that's minus 6 all over x minus 2, okay, with respect to x, then plus the integral value of the other is what's the other? The other is 9, right? That's going to be 9 divided by x minus 3 with respect to x. So it is not easy now for me to evaluate this this integral value. Okay, so how do I do that? Of course, you know that the minus 6 is a constant. I can take it to the back. I take it at the back of the integral value. So this is going to be equal to minus 6 being a constant or a coefficient. Okay, so I'm left with 1 all over x minus 2 with respect to the x. The same thing happens here. 9 goes at the back. 9 times the integral value of x minus 3 with respect to x. Okay, so let's now do this. So the integral value of 1 all over x minus 2 is ln. Please already know that it's going to ln x minus 2. Then plus 9. The integral value of 1 over x minus 3, that's going to give me ln x minus 3. Okay. Then don't forget to add the constant of integration. Okay, so if you wish, you can still simplify further. How do I simplify further? This is something as saying of this minus 6, okay, is the power of x minus 2. So by the law of logarithm, it's something as saying x minus 2 raised to the power of minus 6. Then of course here ln x minus 3 raised to the power of 9. Okay. Don't forget the plus c. Okay, so this is something as ln 1 all over reciprocal. Remember reciprocal, okay? This reciprocal 1 all over x minus 2. Then raised power 6. By reciprocal, then the minus disappears. Okay, then plus ln x minus 3 raised to the power of 9. Then plus c. Okay, so let's finalize this now by applying multiplication law of logarithm. Remember multiplication law, when two log, okay, of course ln is actually a natural log. So now when two log are adding, okay, when you add two log of the same base, then you can multiply the log. So this is something as okay, evaluating ln 1 all over x minus 2 raised power 6 times. So this is something as ln x minus 3 all raised to the power of 9 divided by x minus 2 all raised to the power of 6, then plus c. Okay, so that is my final answer. That is how we integrate by applying partial fraction. So I hope that is well understood. Okay, I can still bring another example. Let's look at the integral value of let's say you have 2x minus 1 raised to the power of 2x minus 1 all over x plus 1 and x plus 2. Okay, with respect to the x. So you know very well that this can be solved by applying partial fraction. So one denominator is x plus 1 with respect to the x, okay, with another integral value of b all over the other denominator, which is x plus 2. Okay, so with respect to x. So now let's solve this. Okay, so this partial fraction is equivalent to, let's simplify this fraction. Okay, so the LCM of the denominator is still x plus 1 and of course x plus 2. So if I start dividing, this cancels this. I'm left with this. So it's going to be a times x plus 2. Alright, then plus. This cancels this. I'm left with this b times x plus 1. Alright. Okay, of course, let me still write this down. 2x minus 1 divided by x plus 1, and of course x minus 2. They will cancel out, so I'm left with 2x minus 1 is equivalent to is equivalent to, here I'm gonna start evaluating. Okay, let me bring this down. This is gonna be x plus 2 plus b into x plus 1. Alright, so now let me eliminate b. If I want to eliminate b, I'll put x to be equal to minus 1. So any place I see x, that's going to be minus 1. So here I'm going to have 2 into minus 1. Okay, 2 into minus 1, then minus 1. A is going to be equal to minus 1 plus 2, then plus b, bracket open, minus 1 plus 1. So this makes this bracket to be equal to 0, so b is eliminated. Now left is minus 1 plus 2, that's a, then minus 2. So a is equal to minus 2. This is equal to no, not equivalent. Okay, so for me to eliminate a, I have to put x to be equal to minus 2. So here you go. So I'm having 2 into minus 2 minus 1, then equivalent to a, bracket open, minus 2 plus 2, okay, then plus b, bracket open, minus 2 plus 1. Alright, so now this is 0, so I'm left with b, 2 times minus I made a mistake here. This is minus 2 minus 1. This should be minus 3. Minus 3. So a is minus 3. So now this is gonna be minus 4 minus 1. This b is minus 5. So having b to be equal to minus 5. So now the integral value of 2x minus 1 divided by x plus 1, then x plus 2, all with respect to x, is now going to be equal to the integral value of my a, which of course is minus 3, right? Minus 3 divided by x plus 1 dx, then plus the integral value of minus 5 divided by x plus 2 with respect to x. So now applying the principle of integration, minus 3 goes at the back as a constant. Okay, so I'm left with 1 all over x plus 1 okay, with respect to x, the integral value of 1 over x plus 1 with respect to x. Then of course minus 5 goes at the back of the integral value because it's a constant. Okay, so it goes at the back. That is going to be minus 5 integral value of 1 all over x plus 2 with respect to x. So now let's resolve. So this is going to be minus 3 ln x plus 1, then minus 5 ln x plus 2, then plus my c, and of course you know this by law of logarithm is gonna be okay ln 1 all over reciprocal. Don't forget this is gonna be s plus 1 is power minus 1 over minus 3. Okay, so to actually evaluate that reciprocal, I'm going to do 1 all over, okay, x plus 1 raised to the power of 3, and the same thing happens here. Okay, so this is gonna be plus okay, just minus, let me okay, keep it as minus. This is gonna be minus ln x plus 2 raised to the power of 5, then plus c. Okay, so now multiplication law of log is no, not multiplication law, division law, because here now I'm dealing with minus, right? So there's gonna be division. So division law, there's gonna be ln of 1 all over x plus 1 raised to the power of 3, then divided by x plus 2 raised to the power of 5 plus c. And of course, if you do this, you know very well that for me to change the division sign to multiplication sign, okay, I have to invert the divisor. So my final answer is going to be equal to ln 1 all over x plus 1 all cube, then times x plus 2 all raised to the power of 5, then plus c. Okay, so that's my final answer. So I hope that is well understood. Okay, so we're going to look at more questions in the next video, right? See you in the next video. Thank you very much.